Our last topic for the semester, and really the culmination of everything we've done since the very start of the semester, is this notion of hypothesis testing. It really is the strength of using statistics to drive the modern scientific method. And it's the reason that basic statistics is such an important piece of your study in no matter what field you want to go into when you go to university. Now, suppose that a researcher suppose there's a skin condition, and let's suppose that from vast experience, we know that if left to itself, left untreated, that this condition will, let's just pick a number out of the blue sky. Let's just suppose that we know that this skin condition will dissipate on average in 110 hours after onset. So let's just suppose that that's the case. In 110 hours, if left to itself, it will dissipate. But a doctor believes that there's a treatment that can be given. And what would the researcher think? He thinks that when you try this treatment, that the recovery time, what would you think would happen? They would contend that the recovery time is significantly less than the average of 110 hours. Suppose that the research, now we understand what would have to happen. You would need to have a double-blind experiment and all the structure and all the details of what goes in to the process of conducting a clinical trial. Suppose we've done all that, we go to all this effort, all this time and expense, and we find that we tried our ointment on a treatment on a vast number of people, and let's suppose that left to itself, the recovery time is on average 110 hours. Suppose we find out on our treatment the recovery time is on average 109 hours and 20 minutes. Now, that probably does not fall into the category of a significant result. We go to all this effort, and all that we've done is we've reduced the recovery time by 40 minutes. That probably would not be considered a significant result. On the other hand, suppose that we do our treatment, we do our large experiment, we do our clinical trials, and we find out we've reduced the recovery time on average from 110 hours to an average of, let's say, 15 hours. That almost certainly would be regarded as a significant occurrence, a treatment effect that is unexplainable by random chance. And so that's what we want to investigate. Now, if 109 hours is considered not significant and 15 hours is considered significant, what that means is somewhere in between, now we don't know where, but somewhere in between, there is the cutoff line between what we consider to be significant and what we consider not to be significant. Part of what we're going to be doing is discussing how do you find that cut value? How do you find where is the dividing line between the significant and not? Another setting might involve an agriculture researcher believes that a certain fertilizer treatment can cause a significant increase in the yield per acre of a certain crop in an area. So what would you do? You would treat certain crops, certain fields, and others that are experimental, and others that are not treated, and then you would compare the results between the two. Let's suppose that the yield per acre is, again, I'm going to pick a number out of the blue sky. The yield per acre is 150, and using our treatment, we find out the yield per acre is 151. That's probably not considered a significant and meaningful increase in crop yields. On the other hand, if it's gone from 150 to 350, that would probably be considered a significant result. Notice what the researcher's trying to do. The researcher's trying to show in the ointment, in the skin condition example, they're trying to show that the recovery time is significantly less than what we thought it was. In the crop example, we tried to show that the yield is significantly greater than what we thought it was. And that's an overarching principle. There are, in the notion of hypothesis testing, there are always two competing hypotheses. One of them is called the Null Hypothesis. Null is German for zero. The Null Hypothesis, and the symbol for the Null Hypothesis is H subscript 0. That's why null is the German word for zero. The Null Hypothesis. This is everyone on earth does it this way. If you go to any other university, any other text, any other course, you're going to see H subscript 0. H subscript 0, or H sub O. And so with my Missouri slur, I'll say H sub O, H sub O. H subscript 0, HO is the Null Hypothesis. The other is called the Alternate Hypothesis. Sometimes also called the Research Hypothesis. Calling something the Research Hypothesis or the Alternate Hypothesis, those are synonymous. And the typical symbol for the Alternate Hypothesis is H subscript 1. So it's binary, 0 and 1. H sub O and H sub 1. The Null Hypothesis, the Alternate Hypothesis. This is universal. This is most common. This is rare. Some textbooks will say H subscript A for alternate. Some textbooks will say H subscript R for research. Those are rare and even becoming more rare of late, but you might see that in some textbook somewhere. Our text uses this, and this is the most common. Now, the research, as the name implies, the researcher is trying to establish the research hypothesis. Usually, the alternate hypothesis or the research hypothesis, this can be thought of as the researcher researcher's viewpoint, or this is what the researcher is attempting to establish. The null hypothesis is considered the default viewpoint. In the case of our skin condition, the null hypothesis, this is what we have believed it to be all the time, and until led to believe otherwise, this is the default position we will fall back on. In that case, it was the, whatever I said, 110 hours is the average time to recovery. In the crop example, this is the 150 bushel per acre. This is the heretofore we have believed this to be the case, and until we have convincing evidence, we will continue to believe this to be the case until led to believe otherwise. This is what the researcher is trying to establish. So the null hypothesis is the default viewpoint, the conservative viewpoint in the true meaning of that word. The conservative viewpoint, which is the one we're going to fall back on, this is what the researcher is trying to establish. The null hypothesis always involves equality. The null hypothesis always involves equality. The alternate or the research hypothesis, H sub 1, this always involves inequality. We believe the recovery time will be less than. We believe the yield per acre will be greater than. Not greater than or equal to. We believe the yield per acre will be significantly greater than. So this involves inequality. In some circumstances, this involves equals. This is not equal to. And so this is the basic structure or the basic terminology for hypothesis testing. And so, again, what we're going to be doing is fleshing out more of the details of how this procedure is done. It is the structure behind basic scientific research Anything that you will do when you go to university, anything you do if you ever go to graduate school, based upon research, is some form or another of this hypothesis testing structure. We'll talk about some of the details now, but this is the introductory terminology. The null hypothesis is the default viewpoint. It involves equality, H subscript 0. The alternate hypothesis, this is the researcher's point of view. It involves inequality, and the symbol is H subscript 1. So more detail on this as we go along.